Batten disease, also known as neuronal ceroid lipofuscinosis disease, is an inherited and fatal neuronal disease which results from mutations in one of 13 genes. Most forms of Batten disease usually begin during childhood. There was a rare case of Batten disease that happened to a small girl which changed her family's whole life. In November 2010, Mila was born pink and perfectly healthy. Before 2, she was very outgoing and active.
5, 6, 7, 8, 9, 10.
However, as she grew up, her mother Julia started to notice the abnormal condition of Mila. Her life quality was affected as she started to become clumsy, having seizure, lost vision, and lost ability to speak and move. Mila was diagnosed with Batten disease. Faced with such challenges, Julia founded a charity in her daughter's name, Mila's Miracle Foundation, in the hope of curing this incurable disease. Her end goal was to raise money for research on gene therapy. However, treatments for such diseases are almost non-existent. In January 2017, a neurologist and neurogeneticist, Dr. Timothy Yu, saw the post that was shared by Julia on Facebook and wished to help this poor little girl. Upon the effort of Yu and his team, they developed a drug which was customized just to Mila. Initially, Mila was showing signs of improvement after treatment, but unfortunately, Mila left this world in February 2021 at the age of 10.
Batten disease constitutes a group of neurodegenerative lysosomal storage disorders. Lysosomes are the essential organelles acting as the waste disposal system to break down the cellular waste and recycle molecules. Any defect in genes involving in the lysosomal cascade will impair the degradation function of the enzymes, leading to the abnormal buildup of lipid-containing residues called lipofuscins. Batten disease subtypes are classified differently based on the mutation in 13 different CLN genes. However, in Mila's case, the little girl was discovered to have the CLN7 disease caused by the mutation in MFSD8 gene on chromosome 4. MFSD8 protein is a multi-span integral lysosomal membrane protein, whereby the proteins of major facilitator superfamily are responsible in transporting the substances across the cell membranes. These proteins are highly expressed in cerebral cortex and the cerebellum. Cerebral cortex consists of 4 lobes encompassing a broad range of brain functions, including some higher-order brain functions, controlling personality and behavior, modulating the speech and voluntary movement, as well as processing visual, sensory, and auditory info. Meanwhile, cerebellum is responsible in maintaining the balance, posture, and the coordination of movement. Batten disease follows an autosomal recessive inheritance pattern, whereby the offspring need to receive 2 defective gene copies from each parent to manifest the disease. However, as Mila's doctors sequenced the protein coding region of Mila's genome, they only disclosed 1 defective CLN7 gene from her father. Considering the rapid progression of Mila's symptoms, prompt action on seeking for the another underlying mutated gene via whole genome sequencing is needed. Fortunately, Dr. Timothy Yu, who works as a neurologist and neurogeneticist at Boston Children's Hospital, had read and acknowledged Mila's condition in a Facebook post. Without any delay, Dr. Yu and his team worked on sequencing the whole genome of Mila. As they analyzed the sequences, they noticed that a section within the non-coding portion of CLN7 gene of Mila's mother did not align properly with the normal CLN7 gene sequence. And followed by a closer inspection into the sequencing data, they further detected the insertion of retrotransposons in mother's genome, which is a short mobile DNA sequence that are able to self-amplify and bounce around the genomes. This results in generating early splicing within the exon sites of CLN7 gene, and in turn producing the shortened and unfunctional lysosomal proteins.
Although there are various forms of Batten disease, all forms share similar signs and symptoms at different beginning age and progression rate. Batten disease usually starts with seizures, cognitive problems, vision loss, problem with speaking, and coordination problems. As the disease progresses, they may develop other signs such as abnormal muscle twitches, personality and behavioral changes, sleep disturbance, dementia, hallucination, heart problems, weakness in the limbs, and eventually progresses into paralysis and death. For our little Mila, she was diagnosed with tibia torsion before she turned 4. Then slowly, she became clumsy and stumbled. Her speech became slow and staccato. When Mila was 6, she was diagnosed with Batten disease after she showed rapid development of blindness, seizure, dysphagia, and inability to stand. Currently, there is no specific treatment that can reverse CLN7 Batten disease that Mila was diagnosed with. Thus, a group of scientists have created a personalized drug for Mila. The drug is designed from the idea of Spinraza, an FDA-approved antisense oligonucleotide drug used to treat spinal muscular atrophy by reassembling the splicing pattern of SMN2 RNA. The scientists came up with an idea by creating a similar kind of drug to cover the defective gene of Mila. After the effort of all scientists, they successfully designed the drug to bind with the defective RNA, hide it and stop the wrong splicing process in order to allow the normal protein production. After they designed the drug, they faced a problem with the long progress of FDA approval. However, Mila can't wait for a long time. The team decided to apply for permission to administer the drug under emergency access. Considering Mila's clinical prognosis, and after appropriate scientific and ethics review, FDA had approved the permission to initiate clinical investigational treatment under an expanded access investigational new drug application. Milasen was manufactured and formulated for clinical administration. Milasen is a 22-nucleotide antisense oligonucleotide with the same backbone and sugar chemistry modifications as Spinraza. Mila received the first dose via a lumbar administration. Through the first years of treatment, no serious adverse effect occurred. Over the next 5 months after first administered, Mila's condition started to stabilize and improve. The frequency of seizures went down drastically from 15 to 30 seizures per day to 5 and 15 seizures per day. Besides, the duration of seizures also declined from each time lasting 1 to 2 minutes to less than 1 minute. Mila also began to able to hold up her own body again and started eating. She even started walking with her mother standing behind her. After years, Mila's disease started progressing again, but more slowly than it had before. Although the drug cannot undo all the damage that has been done and completely cure Mila, this drug is definitely helping and providing her with an improved quality of life.
Initially, Mila's mother was very upset and no longer dreamed about Mila growing up, going to a college and getting married because it was very painful for her. All of the doctors she met told her to spend the most time with Mila. However, she didn't give up to find a way which can help her doctor to recover. Although at last Mila was failed to continue her life, but her family still tried to optimistic and wishes to continue to pave this route to allow other children the chance to have individual genetic therapy. Julia compares the situation she faced when Mila was diagnosed with Batten disease to being handed an empty toolbox. Now, that box contains one truly remarkable tool. If another child has Batten disease caused by the exact same genetic mutation as Mila, and if that child is diagnosed sooner than Mila, then there's a chance they could press pause on the disease and slow its progress earlier. In the future, the mutation that cause rare, often fatal diseases could be targeted with precision medicines just like Milasen. Parents could even be screened before they try for a child to find out if they have mutation that could cause a fatal or life-limiting disease.